Good morning everyone. This is a continuation of previous class. In that class we have seen in detail about innate immune mechanisms. Basically I want to refresh once again. So in immunity is a protection against produced by bacteria against any incoming pathogen. So it is natural response produced by body. So body has various mechanisms to activate that particular response. That is it can be either by innate immune mechanism or by adaptive mechanism. Innate immune mechanisms usually includes the natural sources that are present over the body, like external defenses, internal defenses. External defenses include skin, various membranes and cilia that are present over the body, and when it comes to internal defenses, the blood cells that produces WBC and plasma proteins that are present, like complement factors, cytokines, all those things included in internal defenses. So that's how the various things included in innate immune system. Now we will see about adaptive immune system. Adaptive immune system is a bit more advanced immune mechanism. It is we can say like it is a specifically targeted immune system. That means it produces antibodies particular to that particular antigen. That means whichever the bacteria enters the body, the adaptive system will be able to act upon that particular antigen. When it comes to when we see the innate immune system, that's the scenario will be different. That means it acts in the same way whether a bacteria enters the body or whether a virus enters the body. When it comes to adaptive, that is not the scenario. This is the overview of innate adaptive immune system. It includes usually it includes humoral and cellular responses. Humoral responses are mediated by antibodies. Cellular responses are mediated by T cells. T cells have various subsets of cells. They will directly act upon that particular antigen. So whenever a pathogen enters the body, usually antigen presenting cells will they will coat the bacteria, and these cells try to process the bacteria to certain level, and then they present this antigen presenting cell to the adaptive system. Adaptive immune system it includes T cells and B cells. So before going to that, what is antibody? First we will see about antigen. Antigen is any particular external pathogen or external microbe that enters the body. It may be a particle or a bacteria or a virus or any other cell. So immunogen or antigen is a substance that elicits an immune response. So immunogen and antigen both are used to be, they will present the same thing, but they will vary in a point that, and all immunogens can be antigens, but all antigens are not immunogens. That means certain immunogens can be able to directly initiate the immune responses. When it comes to antigen, the scenario will be different. So now we will see what is antibody. Antibody is that particular cell that is produced against any particular incoming antigen. That means it is produced to combat that particular antigen, to neutralize that antigen. So it is usually produced by plasma cells. Plasma cells are nothing but matured B cells. They have the ability to produce antibodies. And these antibodies possess an essential part of adaptive immune system. And they specifically bind to unique antigen epitope, and they also possess antigen binding sites, thus they help in them. Now what is epitope? Epitope is that portion of antigen that is recognized by or bounded by an antibody. That means antigen, this is the antigen, these are the antibody binding sites. These are called epitopes. Epitopes are the particular regions which can be able to detected by that particular antibody. So there are various epitopes can be seen: B cell epitopes, T cell epitopes. B cell epitopes are recognized by B lymphocytes. T cell epitopes are recognized by T lymphocytes. Upon any inflammation, any infection, B cells tries to produce B cells that are usually present in bone marrow, differentiated in bone marrow. They will reach the sites and they will reach the lymphoid organs. They will produce certain antibodies. They are stored within lymph nodes. So these plasma cells that are nothing but matured B cells, they will produce certain sets of antibodies, in which a portion of antibodies are used to combat infection at the particular time, and a portion of these antibodies are stored for future use. That means whenever a same pathogen enters the body, these stored antibodies directly comes into the scenario or comes into action. That's how the system acts. So there are various types of immunoglobulins can be seen. These are usually found in blood tissues and secretions they are usually antibodies. Antibodies are certainly specific and sensitive. These are various types of isotopes of immunoglobulins, that is IgG1, G2, G3, G4, and IgA1, A2, IgM, IgD, and IgA. We will see what is IgG. IgG comprises of 80% of total immunoglobulins. That means it consists of largest percentage of immunoglobulins components, and it activates complements, crosses the placental barrier, and offers protection even to the newborn. When it comes to IgM, this is the first formed after any inflammation or infection, and offers protection during early part of infection and activates the complements with a valency of 10. IgG is homocytotrophic for mast cells and basophils. Usually its levels are increased in case of anaphylaxis reactions. IgD is extremely present in extremely low levels. It is produced upon B cell stimulation. IgA is the principal immunoglobulin present in exocrine secretions like saliva, tears, etc. It comprises of 1/5 level of IgG, because IgG comprises of 80% of components. When it comes to IgA, it is only about 1/5 levels of IgG levels. It has got resistance to digestion by proteolytic enzymes. They are the active complement in complement alternate pathways. They have the property to activate the complement pathways. So this is the structure of antibody. It has two identical heavy chains, two identical light chains. These are the heavy chains and light chains. Each heavy chain has got constant and variable region, constant region and variable region. Each light chain has same thing, constant and variable region. This is a light chain, this is heavy chain. So constant and variable regions can be detected. Constant region, variable region. This is a constant. So even antibody has the structures like FAB, that is fragment for antigen binding. So these sites have FAB portions, that is nothing but they are the portions where antigen binds, or antibody tries to bind to the antigen. And FC component, that is fragment constant, that is this is a constant portion when it comes to antigen binding portion, and this is a constant fragment portion. If constant region is the base of the antibody, it binds to cell receptors and complement proteins. When it comes to FAB region or antibody region, this is present on variable region of variable region of antibody, and it is the tip of the antibody, binds to the antigen, and it has got specificity of antigen binding determined by VH and VL. So antibodies usually exist in two forms: soluble antibodies and membrane bound antibodies. That means soluble antibodies are secreted into blood and tissues. When it comes to membrane bound, they are found on the surfaces of B cells and also known as B cell receptors. So these B cell receptors detect the circulating antigens present in their body and triggers the activation of B cells. And it also activates Activated B cells either become antibody factories and called plasma cells, and they differentiate into memory cells or B cells. These memory cells survive for several years and are essential for long-term immunity. That means whenever the cell encounters with the same kind of pathogen or same kind of antigen, these memory cells try to provide the same kind of antibodies so as to combat the infection or neutralize that particular infection. This allows the immune system to remember an antigen and respond faster for the next times. So this is the overview of immune system, where we can detect whenever a microorganism enter the body. So certain innate immune responses will come and adaptive immune responses will come into the action. But innate immune system acts in a faster way than the adaptive immune system. So innate immune system comprises of these all cells. They will come into contact with the pathogen immediately after entering that particular cell. These innate immune cells like macrophages, PMNs, they have the capacity to act as antigen presenting cells. That means they have the ability to reveal the receptor sites. That means so that they can be able to detect detected by the lymphocytes. That means adaptive immunity. So whenever these microorganism is not able to digest by the innate immune system mechanism or innate immune cells, these partially binded antigens are supplied to the adaptive immune system so that complete digestion can be taken place, and that's how neutralization of the microorganisms can be occurred. In this adaptive immune system, T cells and B cells will be participate. T cells will produce they produce cell-mediated type of immunity. That means these T cells, by clonal differentiation, they can be differentiated into T cytotoxic cells. These cytotoxic cells directly kill the microorganism. When it comes to B cells, they produce antibodies. Like we have seen so many antibodies against that particular antigen. So that's how the immune host defenses act against a particular incoming microorganism. Thank you.